Hello everyone, welcome to 2.1 motion revision. A test model of a two-stage rocket is fired vertically upward from a surface of the Earth. The sketch graph shows how the vertical speed of rocket varies with the time from takeoff until the first stage of the rocket reach its maximum height. This is a speed time graph. So area under the speed time graph is distance traveled. Distance traveled is area under the graph. So that is 1/2 times base times height, which is 1/2 times base is 10, height is 35. So that is approximately 175 meter. So the maximum height reached by the first stage of rocket is about 170 meter. On reaching its maximum height, the first stage of rocket falls away and the second stage fires so that the rocket acquires a constant horizontal velocity of 56 meters per second. I have shown in green. Calculate the velocity at the instant when the second stage of the rocket returns to the surface of the Earth. Ignore air resistance. We know the total height from the previous, that is 170 meter. We choose downward as a positive reference. Then acceleration due to gravity in y component equals to g. So let's write it down. Displacement formula. S equals to ut plus 1/2 at squared. Displacement is 170. The rocket is traveling horizontally, so initial velocity in y component is 0 times t 1/2 times 9.81 times t squared. From here we can find t equals 2 times 170 divided by 9.81, that is 5.89 seconds. Velocity formula v equals to u plus at. Let's write it down. X component. Acceleration in x component equals to 0. So vx equal to ux. Initial velocity in x component is 56 meter per second. So this is 56 meter per second. We do the similar. Write it down. Y component vy equals to uy plus ayt. So vy equals 2. Since the rocket is traveling horizontally initially, the initial velocity y component equals to 0. So 0 plus 9.81 times time taken is 5.89. That gives us 57.8 meter per second. So this is 57.8 meter per second. Use Pythagorean theorem. V squared equals to vx squared plus vy squared. That is vx squared plus vy squared. Let's plug in inside. 56 squared plus 57.8 squared. That gives us 80.4 meter per second. The question is asking the velocity, and the velocity is vector quantity with the direction. So we need to find this angle. So which is also this angle. So that's the tan. Theta equals to opposite our adjacent. Theta equals to tan vy over vx. Theta equals to tan as 57.8, and this is 56, and that gives us 46 degree. So this is 46 degree. The ball is projected horizontally at 5 meters per second from a vertical cliff of height 110 meters. Assume that air resistance is negligible and use g equals to 10 meters per second. State the magnitude of the horizontal component of acceleration of the ball after it leaves the cliff. Horizontal component of the acceleration equals to 0. On the axis below, sketch a graph to show how the horizontal and vertical component of the velocity of the ball Vx and Vy change with time t until just before ball hits the ground. It's not necessary to calculate any values. Let's write it down the velocity formula. Velocity equals to u plus at. Let's write it down. X component Vx equals to ux plus axt. Acceleration in x component equals to 0, which means Vx equal to ux. Initial velocity in x component is 5 meter per second, which means velocity in horizontal component is constant, and it is 5 meter per second. Let's do the same. Let's write it down, the velocity formula. V equals to u plus at. Let us choose upward as a positive reference. Acceleration due to gravity in y component is minus g. So let's write it down. Y component Vy equal to uy plus ayt. Let's substitute values. Vy equals to initial velocity in y component equals to 0 as the ball is traveling horizontally. So 0 plus minus gt. So that is equals to Vy equals to minus 9.81 t. And let us plot the graph. Initial velocity in y component is 0 and the gradient is minus 9.81. Calculate the time taken for the ball to reach the ground. Time is determined by the y component. And let us choose upward as a positive reference. Then acceleration due to gravity in y component equals to minus g, as acceleration due to gravity is always downward. So displacement formula, s equals to ut plus 1 over 2 at squared. Let's write it down. Y component, sy equals to uyt plus 1 over 2 ayt squared. We choose upward as a positive reference, so acceleration due to gravity is downward. Since the ball is traveling downward direction, sy equals to minus 110. Minus 110 equals to, initially the ball is traveling horizontally, so initial velocity in y component equals to 0. 0 times t plus 1 over 2 minus 9.81 t squared. So if we solve this, t equals to 4.69 second, approximately 4.7 second, two significant figures. Calculate the horizontal distance traveled by the ball until just before it reaches ground, which is asking the range. So s equals to ut plus 1 over 2 at squared. Let's write it down, the x component. Acceleration in x component equals to 0. So that gives us sx equal to uxt. Initial velocity in x component equals to 5 meter per second. And the time taken equals to 4.69. That gives us 23 meter. On the diagram above, sketch the graph that the projectile would follow if air resistance were not negligible. It should have a lower maximum height and a lower horizontal range. Asymmetric with a horizontal range before maximum height, more than a horizontal range after maximum height. The maximum height is lower and shifted towards left, and the pre-peak range is longer than post-peak range. A ball rolls up a table with a horizontal speed of 2 meters per second. The table is 1.3 meter height. Calculate how far from the table the ball will land. The question asking the range, Sx. Let's write down the displacement formula. S equals to ut plus 1 over 2 at squared. Write it down, x component, Sx equal to uxt plus 1 over 2 axt squared. Acceleration in x component is 0. That gives us Sx equal to uxt. We don't know the t, so we need to find a t, and the t is normally determined by the y component. We write the y component now. Let's write it down, y component. Sy equals to uyt plus 1 over 2 ayt squared. Let us choose downward as a positive reference. Then acceleration due to gravity in y component is g, as the acceleration due to gravity is always downward. So that is going to be, since we choose downward as a positive reference, then Sy also positive. So that is 1.3 equals to initial velocity in the vertical component equals to 0 as the ball is traveling horizontally. So 0 times t, 1 over 2 times 9.81 t squared. T equals 2 times 1.3 over, for g, let us use 10. So 10, that gives us 0.51 second. Now let's plug into range formula. So Sx equals to initial velocity in horizontal component, that is 2, time taken is 0.51. So Sx equals to 1.02 meter. Two significant figure, 1.0 meter. For an object thrown at an angle of 40 degrees to the horizontal at a speed of 20 meters per second, draw a graph of horizontal velocity against time, vertical velocity against time, and acceleration against time. Let us do the horizontal velocity against time. So horizontal component of initial velocity, that is adjacent cosine theta equals to ux over u, and ux equals to u times cosine theta. Initial velocity is 20 times cosine 40 degree. That gives us 15.3 meter per second. Let us write it down, the velocity formula. X components, Vx equals to ux plus axt. For projectile motions, ax equals to 0. So Vx equal to ux, and initial velocity is 15.3 meter per second, which means the horizontal component of velocity is constant, and the value is 15.3. So B, vertical velocity against time. Before plotting vertical velocity against time, let us find initial velocity in vertical component. That's the opposite. So sine theta equals to u y over u, which means u y equals to u times sine theta. Initial velocity is 20 times sine 40 degree. That gives us 12.9 meter per second. Now let's write it down, the velocity formula. V equals to u plus at. Let us write it on y component. Vy equals to uy plus ayt. We choose upward as a positive reference. Then acceleration due to gravity in y component equals to minus g. Vy equals to initial velocity in y component 12.9 plus acceleration due to gravity in y component minus gt. That gives us Vy equals to 12.9 minus 9.81 t. So let us plot that graph. Initial velocity is 12.9. The gradient is minus 9.81. We also need to find the time here. So when the object reaches highest maximum height, the velocity becomes 0. And we can find a t here. T equals to 1.3 seconds. This is 1.3. Acceleration against time. Acceleration in x component equals to 0, and acceleration in y component equals 2. As we choose upward as a positive reference, then acceleration due to gravity is always downward minus g. which equals to minus g, that is equal to minus 9.81 meter per second. Then our graph is gonna be minus 9.81. A cruel hunter takes aim horizontally at a chimp that is hanging from the branch of tree, as shown in the diagram. The chimp lets go of the branches as soon as the hunter pulls the trigger. Treating the chimp and bullet as point particles determine if the bullet will hit the chimp. Very interesting question. Don't try this. In time t, the monkey will fall a vertical distance sy. Let us write it down, the displacement formula. S equals to ut plus 1/2 at squared. We choose downward as a positive reference. Then acceleration due to gravity is always downward. So a y equals to g. So let's write it down, y component for the monkey. So sy equals to, initially the monkey is at rest. So 0 times t plus 1/2 gt squared. So sy equals to 1/2 gt squared. So in time t, the monkey will fall a vertical distance. Sy equals to 1/2 gt squared. Now let's take a look at the bullet. Let's write it down, the y component as well. So sy equals to, initially the bullet is traveling horizontally. So y component equals to 0. So 0 times t plus 1/2 downward as a positive reference. And acceleration due to gravity is downward, so g t squared. Simplify, sy equals to 1/2 g t squared. In time t, the monkey will fall a vertical distance equal to this, which is equals to, but so will the bullet. And hence, the bullet will hit the monkey.